Hello everyone, welcome to AET Tech Talk. My name is Narala Siddhartha. My roll number is 20951A6744. My subject is embedded systems. Today I am going to discuss about a cloud assisted malware detection and supervision framework for wireless multimedia systems in IoT based on dynamic differential game. As a novel dynamic network service infrastructure, Internet of Things has gained remarkable popularity with obvious superiorities in the interoperability and real-time communication. Despite of the convenience in collecting information to provide the decisions basis for the users, the vulnerability of embedded sensor nodes in the multimedia devices makes the malware propagation a growing serious problem which would harm the security of devices and their users financially and physically in wireless multimedia systems WMS. Therefore, many researchers related to the malware propagation and suppression has been proposed to protect the topology and security of wireless multimedia network. In these studies, the epidemic model is of great significance to the analysis of malware propagation. Considering the cloud and state transition of sensor nodes, a cloud assisted model for malware detection and the dynamic differential game against malware propagation are proposed in this paper. Firstly, a SVM based malware detection model is constructed with the data sharing at the security platform in the cloud. Then, the number of malware infected nodes with physical infectivity to suspectable nodes is calculated precisely based on the attributes of WMS transmission. Then the transition among WMS devices is defined by the modified epidemic model. Furthermore, a dynamic differential game and target cost function are successively derived for the Nash equilibrium between malware and WMS system. On this basis, a saddle point malware detection and suppression algorithm is presented depending on the modified epidemic model and the computation of optimal strategies. Numerical results and comparisons show that the proposed algorithm can increase the utility of WMS efficiency and effectively. Numerous intelligent sensor nodes with constrained computational capabilities and security mechanisms are currently embedded into various multimedia devices worldwide. As an emerging urban infrastructure, the Internet of Things with multiple wireless multimedia devices is increasingly gaining attention in the field of next generation information perception and massive information processing. Mobile application and ubiquitous connectivity provided by the IoT have been a indispensable part of our daily life for work, banking, tasking, entertainment, and even medical treatment. Wireless multimedia system WMS is widely adopted to continuously collect mass information and control the state of remote equipments. The data collected by multimedia devices traditionally includes temperature, voices, and binary images. Since the transmitting power and processing capability is constrained, the sensor nodes embedded in multimedia devices deliver the data to neighbors according to routing table and optimal path. The distributed topology of WMS makes it easy to transmit data to the sink ultimately. Then the access point between the sink and cloud platform is constructed for data aggregation, cloud computing, and other further services. Finally, the processed results will be presented to the clients again. Malware such as malicious codes, worms, viruses, and reprogramming frames can easily infect the target nodes and seriously threaten multimedia devices such as the wireless routers and terminals with the constrained storage, limited transition distance, and finite battery. Alternatively, both the domestic and international achievements indicate that a new generation of wireless reprogramming protocols are equipped with the equipped with the functions to reconfigure sensor nodes in WMS without physical contact. This property provides the convenience of network construction. At the same time, it brings the possibility to execute malware propagation throughout the WMS. Due to constrained resource, the sensor nodes in WMS is of low authentication intensity and intrusion detection capability, which is seriously vulnerable to the malware propagation with a self-replication instinct. Besides, the property of multi-hop path in distributed network brings the flexibility and convenience of the data gathering to sensor nodes with the increase of great concerns for malware infection. Malware can read data from and write data to the memory cache and eavesdrop on the privacy data gathered or relayed by the infected nodes. What's more, the infected nodes can broadcast the malicious codes to the neighbors for further propagation. Thus, in order to promote the domains of IoT application, it is crucial to construct the malware detection and suppression model to prevent the malware propagation in WMS. In recent years, many researches related to malware detection and suppression have been illustrated to protect the data and the security of network architecture. Many kinetic equations and state transition graphs that accurately depict the process of malware propagation have been successfully proposed. The epidemiological model in which infected state is divided into two substates can effectively depict the characteristics of malware propagation in one-to-many network. In classical EMM model, the sensor nodes are divided into susceptible S infected IA, quarantine, queue, and recovery are depending on the allocation of behavior sets directed by network system and malware. However, the EMM model is based on the assumption that infected nodes have sufficient computational resource, which is extremely in contradiction with resource constraint WMS. To solve these conflicts, some researchers started to investigate self-learning model for the construction of security traces among susceptible nodes, which introduced Markov chain based graph into the kinetic analysis. But Markov chain does not take it into consideration that coordinator has the ability to broadcast frames to influence the state of sensor nodes depending on the characteristics of malicious codes and cellular automata propagation model. Ping it all forward and examination of classification algorithm to evaluate the malware propagation in the short range wireless protocol. More classical epidemic models are introduced through the combination of multiple features and different states whose state transition graphs are classified as SI, SIS, and SIR for different scenarios. However, these state transition architectures need further improvements in reflecting actual communication modes of multimedia devices. Considering the cloud assisted framework and specific states in WMS, the modified epidemic model for situation awareness is expanded, which is one of the highlights in this topic. In addition to the calculation of nodes in different states, optimal strategies for malware suppression are also emerging as important considerations. The coordinator can immune suspectable nodes according to the strategy, updating and broadcast security patches to cure the infected nodes. The state transition of nodes can be influenced by communication parameters which are controlled by the WMS and malware. Thus, the crucial problem is to acquire the Nash equilibrium of the dynamic differential game based on modified kinetic equations. A cloud-assisted malware detection and super framework for wireless multimedia systems in IoT based on a dynamic differential game can find application in various real-world scenarios where security and reliability of IoT devices that handle multimedia data are crucial. Here are some applications. smart home security, healthcare IoT, industrial IoT, automotive IoT, smart cities, agriculture IoT, retail and supply chain, education, energy management, environmental monitoring, entertainment and gaming, smart buildings, logistics and warehousing, fleet management, defense and military. In all these applications, a cloud-assisted malware detection and super based on a dynamic differential game can provide advanced security. Thank you.